Evening, ladies and gentlemen. Thank you very much for giving me voice. Today, I will talk about how in Chinese make the artificial neural network helps in improvement of anaerobic digestion. And the work I delivered today to you is work of Henry Yu from Zhejiang Normal University in China. The work is published in a recent number of Biomass and Bioenergy. The work is entitled "Of Feeding Strategy Determine Flexible Biogas via Shaping Microbial Abundance and Interaction in Anaerobic Digestion." The optimization of anaerobic digestion systems for enhanced biogas production is reliant on the manipulation of feeding regimes and organic loading every second day and every third day with two different loading amounts, wherein the core species determined the methane production regarding the different organic loading. The work is checking turnover likely drove the increased biogas production, while specials contribute to fluctuation of biogas in intermittent feeding regimes. The demand-driven biogas production has a potential for flexible and renewable energy, adjusting feeding regimes and organic loading in biogas. Optimizing system operation to enhance biogas yield and improve organic waste treatment through changes in feeding and regimes and organic loading can influence system microbiota, thereby affecting system performance. Operation challenges that in aberrant anaerobic organisms are known as dysbiosis can lead to altered biogas production properties in anaerobic digestion. Dysbiosis can be triggered by various factors, including fixed type, feeding strategy, and other operational stresses. Despite its importance, the impact of microorganisms on biogas production and the operational stress in AD remains a subject of debate. The role of indigenous microbiota in determining biogas properties, as well as the mechanisms responsible for dysbiosis formation and persistence after different feeding regimes, are poorly understood. Anaerobic digestion systems are commonly employed to treat diverse forms of biomass waste with a diverse microbial community driving the biogas process. Four main metabolic steps, each involving a specific microbial consortia, are responsible for breaking down biomass waste to generate biogas. The final step, mechanogenesis, is crucial for regulating the overall metabolic process, with the relationship between metagens and bacteria playing a crucial role in maintaining stable biogas plant. And the operational disturbances can alter microbial dynamics and interactions, thereby impacting biogas production and their stability. Other problems is microbial richness and interactions during the process. The centrality of metagens in the microbial community is fundamental for accessing biogas properties. Previous studies showed that metagenesis remains stable compared to bacteria under operational stress. The bacteria responsible for acetyl cleavage and carbon dioxide formation is the keystone of methanogens and has extensive connections with bacteria, particularly their close link the syntopic acetate oxidizing zinc pathway. However, researchers on whether and how feeding regimes and organic loading influence species turnover and metagens center interaction are limited. The primary objectives of this study were to investigate the impact of feeding regimes and organic loading changes on microbial abundance, identify the factors driving microbial diversity and its correlation with biogas production, explore the changes in metagens center interactions across different feeding regimes. The investigation was conducted using two continuous stir-type reactors fed with swine manure, which were operated continuously and stably for approximately 1 year before this study. Addressing these objectives, 3 different feeding regimes with 2 loading amounts were designed. The study prioritized the assessment of microbiota changes in response to feeding strategies and aim to identify keystone taxa that may drive biogas properties. An experiment was conducted using 2 sets of 20 liters continuous stirred anaerobic digestion system treated with pig manure. So we have 5 moles of pig manure, and pig manure was in water content from 90% to 83% in 5 parts. So 88, 87, 85, 83. And total solid were in K of 83 up to 16%, and this pig manure was collected from large-scale pig farm located in Zhengzhou, Chinese. The pig manure had different content with the initial pH 7.91 for the following experiment. In order to verify effect of feeding strategy on biogas production, the experiment was designed with different loading levels and operated for all of 99 days and divided into 5 stages based on biogas trends. During first phase, determined as feed 1, the fresh swine manure was daily for 20 days. Then in the second phase, so 88%, the 300 gram was loaded intermittently for every 2 years for 21 days. In the third phase, feed 3 was fed daily for a total of 21 days. In the fourth phase, the 5 grams swine manure was replenished intermittently for a total of 21 days. Finally, in the fifth phase, The 500 gram swine manual was replenished every 2 days for 17 days. A striking bagasse decline was obtained in this stage. The swine manual and main process parameters were listed in Table 1. The running parameters of two bioreactors indicated gas production using wet gas flow meter and gas composition using measured at room temperature in standard atmosphere. Digested samples were stored at minus 80 degrees Celsius before use. The collected sample were then used for DNA extraction, and the details of extraction high sequences were put like for standard PCR products. The raw sequences were learned and analyzed via the pipeline for quantity controlling following a clustering similarity. Specialist annotation was performed with reference to the Green Gear Giant database, and sequences were obtained with a minimum of 29,445 sequences per sample. The statistical analyses were conducted using R software. The ANOVA was used to test the differences among the different feeding strategies and to analyze data from the first and second axis of the PCA analysis to verify significant differences expressed by p-values. Linear regression was significant differences expressed by p-values. Linear regression was performed using the base package to examine the relationship between among species. The changes in the relative abundance of microorganisms using different feeding strategies were demonstrated based on the phylum level and family level, with the species at the family level being further being divided into rare species, those with less than 0.1% in all samples, dominant species more than 1% abundance in all samples, and median species between 0.1 and 1% abundance in all samples. The microbial beta diversity and occurrence analysis were based on the prior study. The Kirk also oxidation process were calculated by connectors in networks at the top 10 processors, and the Venn diagram was used to identify the core base above on calculation. As a result, results were obtained, Shannon index impacted production, however limited regarding how feeding's richness and reach, and these show that relative abundance detected selected the dominant families indicated the level above 1%. So, well, such that distinct and well, and distinct, more distinct, were used by bimetallocyanide as and close to that. So almost 50-60% was by Clostridia and Metallocyanide. The list were less up to 40% was Streptococcus and Lactobacterias. In this big swallow, the list was protein, bacteria, firmicutes, so fungi, and these shares what's obtained in this bacteria of. So these shares that showed us that how this changes to Clostridium. So this give the allow us to isolate to protection of methanoبacteria and Clostridium. So these by high organic loaded feeding regimes has negative effects of microbial richness, especially at higher, but didn't affect the keystone dominant metagens responsible for maintaining reasonable biogas production. The feeding regimes and loading demand stimulates strengthen connection between keystone metagens. So it is such feeding for by increasing and more total solid or slurry, it makes strength of metal process. So this is important here, and result were fit thing for, and if we come more this stable addition, the afterfeed was almost only two species. So we by this stressing we use to uh, have lower bacteria ingredients with the impact with this result revealed that intermittent feeding strategies stimulated more positive microbial connections than continuous and high lowering regimes. Both feeding regimes display distinct biogas production. The high loading stage exhibited greater modularity and connectivity, which may contribute to overall higher biogas production. The keystone responsible for biogas production were identified and labeled in the network, solidifying their effectiveness as an indicator of system functioning. Then giving to the libraries used by artificial neural network that this is working and allowing better the prognosis of experiments. The deeply uncover microbial reason driven the distinct biogas population. Then, therefore, the high organic loading more promoting more connections centered around methanol bacteria populations. And because the network uncovered that species interaction was quite similar. There might be reasons that occurs different biogas production from 80 to 90 from 2 to 6 thread connection. The kill connector. The distinct biogas production observed intermittent feeding in high loading treatments can be attributed to different microbial mechanisms. The microbial reaches, but the treatments had different effects of microbial bundles. The dominant taxa were methanobacteria with Clostridia and rare synotropic thermobacteria exhibited fluctuation in response to the feeding regimes they remained. The changes in beta diversity and important abundance had direct impact in the microbial occurrence revealed that intermittent feeding exhibited more position links than high clothing treatment. These findings suggest that observed differences in microbial community structure and interactions may have contributed to distinct biogas production between two treatments. The result demonstrated that both feeding and a high loading significantly influenced microbial abundance and beta diversity, leading to changes in microbial network. Notably, the study revealed that the combined strength of methanogens and bacteria plays a critical factor in determining biogas production. Given the distinct biogas production, these two stages from 87 to 88 of water presence, the formula suggested that co-taxons significantly contributed to methane production and might determine system functioning in biogas plants. For avoiding failure, biogas demand feeding strategies should be carefully monitor changes in cross species and functional microbial interactions throughout the microbial biogas production process. So thank you very much for listening.